Good morning बच्चों. Today we will discuss some PYQs based on delta G equal to delta H minus T delta S. यहाँ पे delta G is the Gibbs free energy change, delta H is the change in enthalpy and delta S is the entropy change and T is the absolute temperature. Suppose हमें एक equilibrium reaction दी है X gives Y. In this case, because the reaction is at equilibrium, so delta G will be 0 and we can say that rate of forward reaction is equal to rate of reverse reaction. Now what happens when delta G is less than 0? In this case, the forward reaction will be spontaneous. Forward reaction will be favored or will be spontaneous. And the Y will be the major product. In this case, Y will be major product because forward reaction is favored when delta G is less than 0 and when delta G is greater than 0. In this case, the reverse reaction will be spontaneous. Reverse reaction will be spontaneous, or we can say that in this case X will be the major product. X will be the major product. Okay, so this is the concept of delta G. When delta G is equal to 0, the reaction is at equilibrium. When delta G is less than 0, the forward reaction will be favored and the yield of Y will be more, and when delta G is greater than 0, the reverse reaction will be favored and X will be the major product. Now we will find out under what conditions this delta G will be negative and under what conditions the delta G will be positive. तो उसके लिए हम इस रिएक्शन इक्वेशन को दो, we can write this as the summation of two terms, that is delta H plus minus T delta S. अगर हमारे दोनों टर्म्स नेगेटिव हो जाते हैं, then delta G will be negative irrespective of the temperature, and in this case the forward reaction will be spontaneous. It means when delta H is negative and when delta S is positive, if both these conditions are met, then first term will be negative, the second term will also be negative, and delta G will be negative. So we can say in this case forward reaction will be spontaneous, will be always spontaneous irrespective of temperature, whatever be the temperature. Now let us take the second case where both the terms are positive. That means when delta H is positive and when delta S is negative, then we see that both the terms become positive. In this case, the reverse reaction will be spontaneous and forward reaction will be non-spontaneous. So reverse reaction will be spontaneous and forward reaction will be non-spontaneous, whatever be the temperature. So these are the two extreme cases. Now we will take the case where one term is positive and the other term is negative. Suppose पहला हम केस लेते हैं when delta H is say positive and when delta S is negative. Now we see, when delta S is positive, means first term is positive and second term will be negative. So in this case, this reaction to become spontaneous, this negative term has to be higher than positive term, then only the summation will be negative. So for negative term to become higher, this temperature has to be higher than delta H divided by delta S. When this temperature is higher than delta H upon delta S, then only this delta G will become negative. And this is understood by the Le Chatelier's principle also, because delta H greater than 0 means this is an endothermic reaction, and we know that endothermic reactions are favored by at high temperatures. So when temperature is higher than delta H upon delta S, then forward reaction will get favored. And now let us take the second case where delta H is less than 0. That means first term is negative and second term is positive, means delta S is also less than 0. In this case we see that first term is negative, second term is positive. For this reaction to become spontaneous, the positive term should be less. That means temperature should be less than delta H upon delta S. More, then only this forward reaction will become spontaneous. And it is understood by Lee-Chatelius principle also, because delta H less than 0 means these are the exothermic reactions, and exothermic reactions are favored at lower temperatures. So that is how we explain the signs of delta G, which determine that whether forward reaction will be spontaneous or reverse reaction will be spontaneous, and at what temperature forward reaction will be spontaneous, and at what temperature reverse reaction will be spontaneous. Okay, that means when at a temperature when delta G becomes negative, then forward reaction will be spontaneous, and at a temperature where delta G becomes positive, the reverse reaction will be spontaneous. Now we will take some numericals based on PYQs just to clear the concept. The first we are taking of 2007 JEE. This is a multiple choice question. Here it is asked that for the process H2O liquid gives H2O gas at 1 bar and 373 Kelvin, we have to find the correct statement. So that is with respect to delta G and delta S. Whether delta G will be negative, positive or 0, whether delta S will be negative, positive or 0. We know that the system is at equilibrium, so delta G will be 0, and as liquid is getting converted into gas, so randomness is increasing, so delta S will be greater than. So that is the right option. The second question was for the reaction, there is a reaction given, that is 2Cl gas gives Cl2 gas. Means there are two chlorine atoms, they are combining to make a chlorine molecule, and we have to find the correct sign of delta RH, means heat of reaction, what is the sign, and delta RS means what will be the sign, that is whether it will be 0, negative or positive, whether delta RS will be 0, negative or positive. Now we know that this is a formation of bond taking place where two chlorine gas atoms are combining to form a chlorine molecule. So with the formation of bond, the energy is released. So we can say that delta H will be less than 0 because the formation of bond is taking place. Okay, and what about delta S? Delta S will be less than 0. Why? Because two chlorine atoms are combining to make a molecule of chlorine, so randomness is getting decreased, so delta S will be less than 0 and delta H will be less than 0, means it is an exothermic reaction. Okay, for exothermic process. Now we take 3 more examples, then we will wind up this session. The next question is this is a reaction is given to us, that is A plus B gives C plus D. And here delta H is given to us as minus 10,000 joule per mole. That is change in enthalpy. And delta S is given to us as minus 33.3 joule per mole Kelvin. And we have to find out the temperatures when the reaction will be spontaneous from left to right, and at what temperatures the reaction will become reverse reaction will be favored. So we have to find the conditions of temperature at which forward reaction will be favored and the temperatures at which reverse reaction will be favored. So we will write delta G equal to delta H minus T delta S. Let us find out delta G. This is minus 10,000, that is delta H, and minus T delta S means minus T. T is given as 300 Kelvin. Okay, so 300 into 33.3, that is delta G. For what we can do, actually we have to find out the temperature. So temperature is not given to us. Sorry. So we have to find out the temperatures above which or below which this reaction will be, forward reaction will be favored, and what temperatures the reverse reaction will be favored. So we calculate temperature when delta G is 0, that will be delta H upon delta S. So this is the temperature at which delta G is 0. At this temperature delta G will be 0. Okay, and this will come as 10,000 divided by 33.3. So this is coming as 300 Kelvin. Okay, now we know that this is an exothermic reaction. So we know exothermic reactions are favored when temperature is less than delta H upon delta S, because in this case delta G will become negative and the forward reaction will be favored. So when temperatures are less than 300 Kelvin, the forward reaction will be favored, and when temperature is more than 300 Kelvin, then reverse reaction will be favored. So that was only asked from us, that at what temperatures the forward reaction will be favored and at what temperatures reverse reaction will be favored. So I hope this question is understood. Now let us take two more questions. The next question is, it was asked in 2019 main. This was asked in 2019 main exam. Here it is given that for the reaction X gives Y, this is an equilibrium reaction, the standard Gibbs free energy change depends on temperature and its value delta G naught is given as 120 minus 3 upon 8 T, and the unit is kilojoule per mole. So delta G is varying with temperature as per this equation, and what is required is what will be the major product is asked. Major product of the reaction mixture. Major product of the reaction mixture at T will be, and four options are given to us. A is Y if T is equal to 280 Kelvin. Second option is X if T equal to 350 Kelvin. C option is X if temperature T is 315 Kelvin and the last option D is Y if T equal to 300 Kelvin. So how we will do? I will just tell you the procedure, then you can do yourself. By putting the value of T, I will calculate the value of delta G naught for each option. Okay. In whatever option the value of delta G becomes negative or is found to be negative, then forward reaction will be favored and Y will be the major product. And all those cases where delta G comes out to be positive, okay, in that case the reverse reaction will be favored and X will be the major product. So that is how you can find out this way. You can solve this numerical and C will be the right answers. So you can solve this yourself and find whether X will be the major product or Y will be the major product as per the temperature given. Now we take the last question, then we will wind up this lesson. And the last question was asked in JEE Mains 2020. And the question says that for the reaction A liquid gives 2B gas. So this is the reaction given to us, and here delta U is given to us as 2.1 kilocalorie and delta S is given to us as 20 calorie per Kelvin at 300 Kelvin. So temperature is given to us, delta U is given to us and delta S is given to us, and what is required to be calculated is delta G. Delta G is to be calculated in kilocalorie. The value of delta G we have to find in kilocalorie. Okay. So we know that delta G is equal to delta H minus T delta S. Here delta S is given to us, but delta H is not given to us. Temperature is given to us. So we will apply the formula delta H equal to delta U plus delta Ng RT. Okay. In this case, what is delta Ng? It is 2 minus 0. That is delta Ng is 2. Because 2 moles of gas, 2 moles of B, which is in gaseous form, is produced, and here there is no gaseous product, there is no gaseous reactant. So delta Ng equal to 2. Now we can apply this and we can find out delta H will be delta U, that is 2.1 kilocalorie, that is 2100 calorie, plus delta G means 2 into R. R we can take as 2 because R is 2 calorie per mole Kelvin, okay, which is also 8.3 joule per mole Kelvin. In this case we take in calories because all the other figures are in calories. So I have taken R as 2 calorie per mole Kelvin and temperature is 300 Kelvin. So delta H comes to be 2100 plus this will be 1200, so it will be 3300 calories. Okay, or in kilocalorie it will be 3.3 kilocalories. So that is our answer. So if delta U and delta S are given to us, delta H is not given to us, then we can find out the delta S by this and by this equation, and then delta G can be, sorry, this is delta G. I have written this is delta G equal to delta H minus T delta S. Oh, sorry. This we have found out delta H only. But what we have to find out is delta G. So this is delta H, then delta G we will find out by this equation, that is delta G equal to delta H minus T delta S. Okay, now delta H we have found out, that is 3.3 minus T, temperature is 300, into delta S is given as 20, and this is in calories, so 30, this divided by 1000, then it will be in kilocalories, so this will cancel out, so it will be 3.3 minus 6, so that will be minus 2.7 kilocalorie. So value of delta G in kilocalorie is minus 2.7 kilocalorie. I am sorry, I thought I have calculated delta G, but it was delta H. Then we put in this formula to find out the value of delta G. So this is the numerical where you are given the values of delta U and delta S. So first you will calculate delta H by this formula, delta U plus delta NGRT, and then utilizing this delta H and delta S, you can find out the value of delta G. With this, I conclude the session. I hope I have covered almost all types of numericals asked in the previous exams, which covers the formula delta G equal to delta H minus T delta S. Thank you and wish you all the best. We will meet in the next session.